Please join me today in our At the Arcade packet. We are going to be on page 316. Please join me there, page 316. We're still talking about linear relationships, and we're looking at tables. So let's start out today's lesson with tables. Now, the very last thing that they tried to teach us yesterday was something called our slope formula. And you have room over on the right side of your page. You can write up there. I'm going to go ahead and write it down here. And I'm going to write slope formula. This formula will follow you all the way through high school. And it looks like this. M is the letter that we use for slope. And we say that just like on a graph, we find the vertical change or the rise. We're finding the difference in the y values. So we say we take one y value, we're going to call it y2, and subtract the other y value of our point that we'll call y1. And we put it over the horizontal change or the change in x, which we call the run on our graphs. And we say x2 minus x1. And I want you to notice the order of my x and y's. If I started with my second point, I said y2. And then on the bottom, I started with the second one, and it was x2. So the order is important. The activity we did where we drew the arrows had to be in the same direction. That's what this is about. This is making sure your arrows are in the same direction. When we get to these first tables, it says use the slope formula to calculate the slope of the line in given table values. I'm going to do both. I'm going to show you that I want to find the change from this y value to this y value, and that would be 12 minus 9, and that's 3. Then I need to find my change in x over here, which would be 8 minus 4, which is 4. So I can see that my change in y, and I also represented it this way, my change in y is 3, and my change in x is 4. So I know my slope is 3 over 4. Now, some of you might like to make that a decimal. If I divide 3 by 4, I could say my slope is 0.75, and that's perfectly fine. And since this is tickets in dollars, we know that this would be 75 cents per ticket. Okay, I'm trying to give you lots of ways to find slope. Let's look at this second table. I'm going to pick two different points, not the first one and the second one. I'm going to say negative 62 minus a negative 2. Well, when you subtract a negative, if you use your calculator, you won't make this mistake, but you remember you end up changing to adding the opposite. So this would become a negative 60. Over here, I'm going to say 4 minus 0, and that's 4. So I have a change in y of negative 60 and a change in x of just 4. So this equals negative 15. So I have a slope of negative 15 over 1. So I could say my slope is negative 15 over 1, or just negative 15. I hope you're feeling pretty good about this. This next one, let's pick some very different points. Let's go from 23 down to 19. Well, if I subtract 19 minus 23, I get negative 4. And then I would go from here to here. Well, I would say 10 minus 8 is 2. So I can see that my change in y would be negative 4. My change in x is going to be 2. And a negative 4 divided by 2 is a negative 2 over 1. So it says this is days past and vitamins remaining in the bottle. So I have a negative slope because I can see I'm taking vitamins out every day. So the rate at which it's coming out would be a negative 2 vitamins each day, or per day. That would be my rate of change or my slope. This next one's very interesting. Hopefully you notice all the y's are the same. So I'm just going to pick the first point and the last point, and you find out that 9 minus 9 is 0. You can do that one in your head for sure. And here we have 40 minus 7, and 40 minus 7 is 33. So my change in y is 0, and my change in x is 33, and this means I have 0 over 33. So I know that my slope for this is 0. And we'll have more time to talk about this. But when all the y values are the same, I know this is a horizontal line. Horizontal lines have a slope of 0. Now on this last part, they've actually just given us points. We don't have a table, so we will use the slope formula. I'm going to call this x1 and y1, and I'm going to call this x2 and y2, and I'm going to use my formula. I'm going to say m is y2 minus y1 over x2 minus x1, and I'm going to substitute my values. y2 is 40, y1 is 25, x2 is 55, and x1 is 10. 40 minus 25 is 15. 55 minus 10 is 45. And if I simplify this, I could say this is 15 goes into both of them, so this would be 1/3. So my rise would be 1/3, and my run would be, my rise would be 1, and my run would be 3. So you could say m is 1/3. On this one, which you don't have to label them every time, I'm just labeling them so you can have an idea of how it might help you to organize your work. This time I switched them around. I said, this is my second point, this is my first point. So I will say m is y2, which was 19, minus y1, over x2 minus x1. And I get 19 minus 3 is 16. 4 minus 24 is a negative 20. And when I simplify this, I realize 4 goes into both of these. 16 divided by 4 is 4. A negative 20 divided by 4 is 5, and this is negative. So I would say my slope is negative 4 over 5. When we get to the second page, page 317, it's going to ask us some questions about these charts. So I inserted a blank page so that we can talk about it. It says, which of these relationships are proportional relationships, and explain your reasoning. I want you to pause my video and go back and decide which of these relationships could be proportional. Okay? Do that for me right now. Okay, I asked you to try to decide which of these relationships, tables, and points were proportional and non-proportional, and hopefully you see none of them are proportional. On the first table, you can see when we divide y by x every time, we get different amounts. So there's no constant of proportionality. On the second table, you can see that my y-intercept is the point 0, -2, so it does not go through the origin, so it's not proportional. On C, once again, there's no constant of proportionality. I get different amounts each time. On D, we know it's not proportional because every value is 9. And we said that the slope was 0. It's a horizontal line. Well, if all the y values are 9, I know that my y-intercept is the point 0.9. So this doesn't go through 0, 0 either. On E and F, I want you to remember a proportional relationship is when the ratio of y over x is constant. And if I divide y by x for these 2 points, I get 2.5 and 0.72. Definitely non-proportional. And then on F, when I divide 19 by 4 and 3 by 24, I definitely get 2 different numbers. It is non-proportional as well. Just a little side check to let you remember that what proportional and non-proportional means. So here we are on page 317. Which relationships in question 1 were proportional? None. And we just explained it on the previous page. Then it wants us to complete each statement to describe how you can tell whether the slope of a line is positive or negative by analyzing given points. And I want you to pause my video and think about that. Okay. Hopefully you did a good job on this. It says complete each sentence to describe how you can tell whether the slope of a line is positive or negative by analyzing given points. It says if the slope of the line is positive, then as the value of x increases, the value of y does something. So let's take a look at this. This is an positive line. This has a positive slope. Well, we can see that as x is getting bigger as we go farther to the right, y seems to be getting bigger as well. So what you would say, as x increases, y increases as well. If the slope is negative, let's sketch that one. This would be an example of a negative slope, and we can see that as x is getting bigger, y is getting smaller. So we would say as the value of x increases, the value of y decreases. Once again, I'm going to go ahead and look at the table on the right. We could say that every y value is the same. And let's go ahead and make a quick sketch of this. It says y is equal to 2. Well, that means that the y-intercept would be 2. When x is 5, y is 2. X is 6, y is 2. On and on and on. So we would just have a horizontal line. All right. So I want you to make a note that it says which relationship is represented by a horizontal line. We would say y equals 2 is a horizontal line, and that the slope is 0. And I like to think about horizontal lines as having no rise at all, so that it is slope of 0. As we move on to activity 2.4, determining if a relationship is linear, this is very important. We've worked with graphs and we've found vertical change and horizontal change, and we know that if there's a straight line, that it doesn't matter which points we pick, the rate of change is going to be the same. The rise and run will all simplify to the same numbers, so the slope's going to be the same. But when we get a table, we can't see that, so we have to explore and find out if the changes will be the same. So we take it 2 points at a time. If you look at this first one, they said point 413 and 928. So 413 and 928 are the first 2 points in our table. I kind of like to do this where I just say, what is 28 minus 13? And I find out that that would be 15. And then I come over here and I say, what is 9 minus 4? And that would be 5. So I could say the rate of change here, my rate of change would be the change on y and the change of x, and that would be 15 over 5, which is 3 over 1. And it works out nicely, and then I can do all the rest of them. If you don't want to do it this way in the table, you can take the points and make a list. And they're telling us we can use our slope formula, basically y2 minus y1 over x2 minus x1. So I'm going to start and say 28 minus 13 over 9 minus 4, which gives me 15 over 5, which is 3, or 3 over 1, whichever way you want to look at it. So I know the change between these 2 points is 3. So I'm going to repeat the process for every set of points in the table. I'm going to start here and say 34 minus 28 over 11 minus 9, which gives me 14 minus 8 is 6 over 2, which is 3. So far they do have the same, but we can't stop. We have to do all the points in the table. So I'm going to do 47 minus 34 over 16 minus 11. And 7 minus 4 is 3. And then I have 4 minus 1. So I have 13 over 5. And if I divide 13 by 5, that obviously doesn't equal 3. 5 goes into 13 twice, and this would be 2.6. So you can see it doesn't have the same rate of change. So when we say, will the ordered pairs listed in the table form a straight line when plotted? You have to say no. And our reason would be that the rate of change between any 2 points in the line is not the same. But another way for us to say it is there is not a constant rate of change. And I hope you paid attention to this, because if you had stopped after the first two, you would have thought it does make a straight line. You have to explore and do all of them. Okay, on the next page, page 319, I want you to pause my video, and I want you to determine whether the ordered pairs listed in each table will form a straight line when plotted. And you need to show your work and explain your reasoning, then come back and check your work against mine. Well, hopefully you did a nice job on this. I want you to look at my two tables. On table A, I used the slope formula and showed you how that might look. And I found out that each time my rate of change could be simplified to 3/2. So I said, yes, constant rate of change. This is linear. Check that one off. On B, I kind of went back to the way I kind of like to do these. And I said the change from 33 to 40 is an increase of 7. The change from 1 to 2 is an increase of 1. And I just went down and saw that every time I went to the next set of points, my Y increase was 7, my X increase was 1. So it had a constant rate of change, 7/1. So yes, it is linear as well. I hope you got that too.